Thank you for weathering a blistery winter day in Tucson. Anyway, it is ominous out there. It's dark and 70. So today is the last day of this lecture series. I know. But it gives you enough energy to come back next year, I hope. And let me just thank again those individuals that have made the lecture possible. Last week I went through in detail those on the left side, on my right side of the screen, and I left out those that really give a lot of money. So Tucson Electric Power and Ventana Medical have been the lead sponsors for this lecture series now for many years. And a little bit about both of them. Ventana Medical Systems is a homegrown organization from one of our faculty members in the College of Medicine, Tom Grogan, who came up with a great idea and invention of how to automate pathology reports. His invention was so great that Roche bought it, everything, a couple of years ago. And they have 1,500 people that they employ in our community. And that's one of the powers of universities that everybody talks about, that they can create technologies that then also benefit the economic development of the city. Ventana Medical, I think, is a prime example of those opportunities. Tucson Electric Power has also been with us for a long time. They've installed more than 300 megawatts of solar energy and in our community. And they've gotten all kinds of awards for innovative programs installing solar in the community as well. So I want to thank those two entities for what they do for us and what they do for our community. I also have other thanks tonight. This lecture series really could not happen from a small group. This is sort of the dark side of the lecture series. This is the committee that reviews all the lectures and makes them as good as you see them. And I can assure you that I go home sometimes when I see some of the lectures from our esteemed lecturers and I go, oh my God. But from when they are heard by this committee to when you see them, they're masterpieces. And that is because of this committee. The committee thinks about the lecture series, what it should be all about, puts it all together, and works tirelessly so that all of us get a first-rate experience. So we should thank all of these individuals as well. And special thanks comes in the next one. Let's see where it comes. John Pollard and Margaret Wilch. Margaret Wilch, who is, where is Margaret? And John, will you both get up? John is a faculty member in chemistry. Margaret is a teacher at the Rincon, Tucson High, at Tucson High. And between them, they've put together this group of teachers that come and listen to the lectures as we all hear them. And the lecturers, after you all hear the lectures, they go off and talk to the teachers, and they create curriculum for high school and middle school. So great to both of you. Lisa Elfring, Annette Prather do it for our own students, so good for them as well. There's students at the University of Arizona that are actually sitting in another room because typically this is too filled up. And there's questions and answers, and they're the ones that have organized that. Carl Philibin, where's Carl? Carl, come up here for a second. Carl is a member of our community. He's a volunteer who actually puts together these beautiful slides before the lectures that we all enjoy with all the detail that's there, and the music. Next time we want Beethoven. The Arizona Public Media has been a great partner with us, and on March 18th, write it down, at 12 o'clock in the afternoon, there's going to be a panel of all of the speakers here for an hour in which you can dial in and listen to all of us talk about global climate change. And I urge you to send me questions that I can then ask the lecturers. March 18th, as long as we get questions from all of you before then, they may show up as a question to the panelists. So the Arizona Public Media not only put together the podcast, but is going to put together this panel and so on. Centennial Hall, if it wasn't for Centennial Hall, we couldn't see or hear anything. So thank you very much for all you do. And the College of Science staff is extraordinary. So thanks to all of them. There's one individual. Bo, will you stand up? She is the one that actually makes it all happen. Bo Baylor. And if you haven't, but of course, none of this would be possible if it wasn't for the great thanks to Tucson. So a big round of applause to all of you for coming here and making this city as extraordinary as it is. Thank you very much. There's more to the global climate change that we have here. Coming soon, there's going to be in the Poetry Center the climate change in poetry. I urge you to go on the website and read about it and perhaps join the poets that will be describing it in their own way. There's also going to be a UA Science at the Book Festival, which is coming on Saturday and Sunday. There's a UA, there's a Science City. I welcome all of you to come to the Science City and see what we do for really mostly our children, but you'll, I'm sure, find interesting things for all of you to do as well. I also want to point out, because clearly all of you are interested in the environment, that the College of Science has created an app. So if you are going on a Sunday or a Saturday up the Catalina Mountains to get away from the heat, just download the app and listen to all of what you're missing unless you have the app in front of you. So we've created an app that tells you about the history, the geology, the ecology, and the astronomy as you drive up the Catalina Mountains. Finally, this summer, this is the 25th anniversary of the biosphere, and we've joined with One Young World to bring in about 500 18 to 30-year-old environmentalists to the biosphere in Tucson to learn about what they're doing, communicate with others, and I'm sure you're going to see more about it in the newspaper. And finally, our colleagues from social and behavioral sciences, there's lots of stuff going on. In the fall, at the Fox Theater, are going to have a lecture series that will be dealing with privacy. I urge you all to go to that as well. And also in the fall, there's going to be a new partnership between the College of Science, the Medical School, and Banner, and we'll be creating a lecture series called The Grand Challenges of Medicine. So all of those things are coming, and I hope to see you at the University of Arizona full-time for the next year. Now let me introduce Jonathan Overpeck. Maybe many of you read about him in the newspaper this morning. He's been in trouble all his life, but we still love him. And Jonathan Overpeck is truly a climatologist. He's been working on climate for a long, long time. And in 2007, he was part of the IPCC, which was a UN organization that was trying to deal with what we knew about global climate change. And he, together with a whole group, was a recipient of the Nobel Prize. That was in 2007. In 2008, he was part of the next group that studied what was going on with global climate change. And if you remember from one of the very first lectures, from 2007 till today, there's been a dramatic shift in our understanding of what goes on in global climate change. Peck, as he's known by everybody, friends and foes, Peck is a Guggenheim Fellow. He is a Thomas R. Brown Chair in Innovation and Science, which we thank the Thomas R. Brown Foundations for. And he's also a Fellow of the American Geophysical Union. And there's only like 0.1% of the members of the American Geophysical Union that can be fellows, and the American Association for the Advancement of Science. So we're all lucky to be listening to Jonathan Overpeck today, educate us a little bit about global climate change. Peck.
All right. Good luck. Thanks. All right, am I live? It's great to be here again. A real pleasure to be joining you. I'm really sad, as you are, that this is the last of our lectures on climate change this semester. My job in going last is to wrap it up, bring it home, but also I hope to instill a sense of hope. Because a lot of times we talk about climate change and it's all doom and gloom. And as you'll see, I'm going to make the case that I think we're living in an extraordinary time right now. All right. The topic of my talk is that climate change is not just a new normal. People like to talk about that as like a buzzword in my field, climate science. You know, everything has changed. And indeed, the Earth has changed. And the concept that the fingerprint of humans is now global is well established. It's in the oceans, it's on land, it's in the atmosphere, you name it. We're having an imprint in the farthest reaches of the planet. And people like to say it's a new normal, it's an Anthropocene. But I want to point out that it's not really a new normal, it's a series of normals. And that's what makes it really a challenge, is that the planet is now changing faster than Mother Nature has ever done, absent an asteroid impact or something like that. So we have to be learning about this planet as it continues to change faster and faster. But I want to talk today, I want to start by talking about the current normal, the latest normal, and then talk about the future normals. That's the challenge, the really big challenge. And then wrap it up talking about optimism. And I was lucky enough to be on this stage about 10 years ago. I don't know how many people were here for our last lecture on climate change. There's quite a few familiar faces in the crowd, although I can barely see you, except up front. And a lot of new faces here. Things have changed immensely in the last 10 years in both climate change science and I think climate change innovation and climate change politics. 10 years ago, we were talking about mostly climate change that is going to occur. Now we're talking about pretty much everything that we were saying was going to occur is now occurring. At least we're seeing signs of it occurring. That gives us a lot more confidence. So that's the second thing, is the science is, we know so much more now. And we're so much more confident about how we're affecting this planet and what it means for us. We also know that the challenge is a lot bigger probably than we thought. I keep turning around and seeing new papers written, new studies, new data that all suggest that this system is changing faster and in a more systemic way than I thought possible in my lifetime. It really is a challenge. But perhaps the most important thing between then, 10 years ago, and now is that I honestly think, if anyone's paying any attention to the newspapers about all the innovations, all of the economic and political things that are going on in this planet, and I'm going to mention some of them, I think we're living in a time that must have been like 100 years ago. 100 years ago, we were leaving steam behind. 100 years ago, horse and buggies were being left behind. Okay? I think we're in that comparable period in Earth history, where we're going to be leaving fossil fuels behind. And the change is going ever so fast now, faster and faster. So let's get rolling. My first part of my talk is to talk about the challenge, where we're at now and where we're going with the challenge, and how we come to have some pretty serious confidence in the future, in our projections of future climate change and their impacts. It turns out that this hand we've been looking at for the past several weeks in this lecture series that has come to symbolize the Earth Transformed lecture series, it had this part of the United States, North America, Mexico, and Central America colored yellow. That's where I think the rubber really hits the road. To give you a sense of how important climate change is to us in the Southwest, in the US and Mexico, how important it is to us as individuals living here and hoping to have our future generations living here, but also for us who pay taxes. I want to talk about two things that are really important that will hopefully give you a sense of why we have to pay attention to this, why it's a good thing that this will be debated in this presidential election more and more. Okay? The first reason is this. We're finding our coasts are getting wetter. There's more frequent flooding. And a lot of people in the newspapers, it's politically correct to say, well, this is just nuisance flooding, okay? But other people who are, responsible for communities on the coast are saying, wait a minute, this is not acceptable, okay? Nuisance flooding, as they know, people who live in the coast, is skyrocketing. It's not just a nuisance, it's an illness in our planet's system, okay? Just in the US coast, nuisance flooding, this is ocean water coming on shore, has increased between 300 and 1,000% since 1960s, okay? This isn't just a nuisance. This is something going on. Imagine like going to the doctor. You know something bad's going on inside your body. We know that these things are happening to our planet. The question is why? When you go to the doctor, you want to find out, why am I having these problems? What is the cure? And we're looking for the same information when we study the planet. And it's really clear where nuisance flooding is coming from because it's called global sea level rise. It's not the same everywhere, but around the planet, just about everywhere, the oceans are coming up onto the coasts. And this plot just shows, over the last 130 years, 3 analyses of global sea level from tide gauges. And in the most recent part of the record, this is all confirmed by satellite observations. The ocean is coming up, okay? It's flooding our coastlines. And it's a real clue in terms of what's coming next. These are the most recent projections I've seen, just came out in a paper a couple weeks ago. They're quite compatible with a host of other projections that have been coming out from the scientific literature, the peer-reviewed literature. And it all suggests, depending on how much greenhouse gas we put into the atmosphere, we could have between a foot of sea level rise by the end of this century, or maybe as much as 4 feet. The U.S. National Climate Assessment suggested it could be as much as 6 feet. Those are the numbers the U.S. military is evaluating to see if that's what they should be planning on. They take climate change very seriously. What people are usually missing, however, is that the real cost of climate change on our coasts is actually quite a bit larger. Why is that? What's going on with our climate system right now? We're trapping heat with greenhouse gases. If we didn't have greenhouse gases to start with, the Earth would be frozen solid. Fortunately, we have the greenhouse gases. Unfortunately, we're adding to them, the concentrations in the atmosphere. And as we add to those, the concentration in the atmosphere, the planet traps more and more radiation that first came from the sun. It turns out, as Joellen Russell pointed out, that over 90% of that heat goes into the ocean. Thank goodness for that, because if it wasn't for that, we would be in a lot worse shape than we are now. Think maybe Venus, okay? But the ocean is taking up all that heat, and like a hot air balloon, as it warms, it expands. So the dominant term in the sea level rise we've seen so far is all that heat going into the ocean, expanding the ocean, and causing sea level to go up around the planet. Okay, but now we're not only melting small glaciers everywhere around the planet, we're also starting to affect the great polar ice sheets, Antarctica and Greenland. And we're starting to see in our sea level record, but we're also starting to see in studies of those great ice sheets from space, from drilling in them, from all sorts of observations around them, that they are starting to lose mass. And they're starting to lose mass, that means ice, at an ever-increasing rate. They're accelerating the loss of ice and the conversion of that ice when it goes from land into the ocean into sea level rise. Well, it takes, we think, centuries to millennia for these great ice sheets to fully respond to the warming that has happened in the past and is going to happen in the future. And this graph, it just is something that isn't played up very often by my community, but is well established. And that is, as we warm the Earth 1 degree, we've almost warmed it about a degree so far, in degrees Celsius. 2 degree, 3 degree, 4 degree. Of course, how much we warm it depends on how much more fossil fuel we burn, how much more carbon dioxide and other greenhouse gases we put in the atmosphere. But if we give these great ice sheets a chance to fully respond, we're not just talking a couple feet of sea level rise. We're talking many meters or as much as 30 feet for a warming of 4 degrees C. And right now, warming of 4 degrees C is what we're expecting if we continue business as usual emissions of carbon dioxide and other greenhouse gases. So in other words, if we want to leave the economy just the way it is, continue to burn fossil fuel without any slowing down, this will be the world we bequeath to future generations. Many, many feet of sea level rise. Now remember, the projections now are up to 4 feet of sea level rise by the end of this century, and then, of course, many more feet. What does that mean for us in Arizona? I mean, we're in Arizona. We're high and dry, okay? But we all know that if something really bad happens in the other part of this country or other countries around the world, Americans from across the country have to step up and help pay for it, whether it's insurance and the insurance premiums we pay, or taxpayer dollars or other forms of covering these disasters. And this is a study that was carried out by Jeremy Weiss here at the University of Arizona. And I was also working with him, but he's the hero, where he took elevation data from the United States. We did this around the globe. And we looked at what parts of the coast would be flooded with 1, 2, 3, 4, 5, 6 meters. And remember, each meter is about 3 feet of sea level rise. So these areas in red, or the darkest red, are the areas that will likely be flooded by the end of this century, okay? And some of these other less dark colors to yellow in ensuing centuries. We really don't know how fast that'll take place. It could be a couple hundred years, it could be several hundred years or longer. But we're going to have a major transformation of our coastlines, and you can tell people will not be vying for those delegates in Florida nearly as hard in the future. If you convert that to communities where our infrastructure is concentrated, now we're looking at communities that have at least 50,000 people on our coasts outside of Hawaii and Alaska. There are 180 of these communities total, and this is by state. You can get an idea of what percentage of these communities will be flooded for these different increments of sea level rise. So by the end of the century, Florida might lose about 30% of its communities, the area of its community. I mean like Miami. I mean like Tampa, St. Pete, Fort Lauderdale. We're talking big communities as well as small communities. By the time we flood up to 6 meters, we're talking in some states like Florida losing about 90%, 80% of its communities, 34 communities. They're larger than 50,000 people. And you can just see for the whole United States in the lower 48, about 40%, 35% of those communities will be flooded out. We're talking big, big bucks here, right? All right. It's not good by any measure, okay? So that's the number one thing I want you to remember. This is science that's really well established. This is heavily peer-reviewed, As you'll see later in my talk, this is all stuff where there's consistency among observations, models, experiments, you name it. We're really confident these changes are going to occur. It's just a question of how much, how fast. The second one is bringing it even closer to home. Okay? It's drought. But it's not just the drought of our parents' era. It's a new type of drought. And I want to explain to you more about this drought, which we call hot drought, because it's basically means to us, what it means to us is that climate change isn't just about global warming. Climate change in the Southwest is about all those things we've been talking about in this lecture series. But first and foremost, if we let climate change go unchecked, it's our water supply. Okay? And let me explain more. Okay, so far, this is like nuisance flooding, right? Oh, don't worry about it. You know, you don't have to worry. It's no big deal. The hot drought since 2010 and before the California drought chalked up about $40 billion of costs and claimed a number of human lives. This isn't just about money. This is about lives lost fighting fires and other unfortunate circumstances. The California drought now in its 5th year, it's fortunately getting a lot of snow right now as I speak. But nonetheless, this California drought is $5 billion and ticking. So this isn't small potatoes. Okay? Think of that when you step on the gas. Okay? This is mainly because of fossil fuel, these droughts. And let me show you what I mean. Okay? First, I want to just show you where the drought is now. We're actually in a 16th year of a Southwest drought. People don't talk about this very often, okay? We talk about the California drought because it's so obviously impacting a lot of people and costing so much money. But the Southwest, including Arizona, especially Arizona, has been in drought for 16 years. And as you can see, we're still in drought. These yellow colors means we're not in drought like California, but things are dry. All right, if you look back over the history of this drought, you can see in 2002, 2004, it was particularly bad. Okay, the drought started in Mexico, went all the way into Canada. In other years, like 2012, that drought moved out onto the high plains. It still was affecting us back at home, but it moved out on the high plains and got in the news as, oh, we have a drought out in the high plains. And then by 13, it was really a panhandle drought, New Mexico drought. I testified before the Senate that year because they want to know what's going on here. Well, this is all part of the same drought, and as you'll see even more in a second, this isn't like the drought of yore. This is a hot drought. It's different, and that means droughts of the future will be different too, and worse and worse. Okay? Now, to understand this and get the full implications, to feel it in your gut, I hope, I want to talk about the Colorado River. Why do I want to talk about the Colorado River? Well, the Colorado River Basin extends all the way up into Wyoming and all the way down into Mexico. 7 basin states and Mexico share the water from this mighty river. Okay? This river has this river basin has some of the fastest growing areas of the country. Yeah, we're starting to grow again here in Arizona. Has many large cities using the water. San Diego uses the water. LA uses the water. Phoenix, Tucson, Vegas, Salt Lake, Denver, Albuquerque. We all share this water. We all depend on this water. Here, the water comes via the Central Arizona Project, that big canal that we built that goes through Phoenix down to us. This basin has many native nations. The native nations have not yet received their full allocation of water. Okay, so there will be more water going to the tribes. But the first and most important thing for you to remember tonight is that this is our sustainable water supply, all of it. Okay? Absent the Colorado River, we're just going to pump our aquifers of fossil water dry, and that'll be the end of the story here, unless we learn to reuse water. Which is something the University of Arizona is putting a lot of research effort into for obvious reasons. But we want our sustainable water supply. Fortunately, this river has the two biggest reservoirs on the in the country. The two biggest reservoirs on the Colorado are Lake Powell in the north, right over the border in Utah, and Lake Mead, right at the border between Arizona and Nevada. Turns out these reservoirs are really doing their job. That's the reason a lot of people in the room probably are saying, what drought? Okay, you've seen very severe, the most severe wildfire occurrence going off the charts. You've seen a lot of forests dying. You've seen other effects if you've been reading the newspaper, but the water supply keeps flowing. That's because these great reservoirs give us a huge buffer against drought. Well, unfortunately, right now, Lake Powell is 46% full. It was 49% full at the end of 2015. It's gone all the way down to 39% full during this drought. So we have better winters and less good winters. Lake Mead is down in the 37-38% range. So these great reservoirs are really getting extremely close to being so low that we get an official shortage, at which time the state that loses water first is Arizona. Okay. Now, now we're going to get some geeky slides here, but I really want to drive home why I think our big problem is temperature increase, global warming, and how that translates into our water supply. At the top here, and this should be attributing Brad Udall and myself, we did this work, and it's really brand new stuff. What we see here in the top graph is the volume of Lake Mead and Powell, the combined volume. And you can see in 1930s we built, I didn't build it, but our forefathers built Hoover Dam, Boulder Dam. And Lake Mead started to fill up, and you can see by the 1940s that lake was full. And then we got into a drought in the 1950s, and things started to go down. Fortunately, we already had plans on the books to start filling Lake Powell. And that's what gets us that second big increase going into the 70s and 80s. Okay? So by the time we get to 1980, Lake Powell is near full, Lake Mead is about full, and life is good. We've got our water problems solved. But then there was a small dip in the 1980s during a drought, and then the drought, the Southwest drought that I have been highlighting in this talk so far, began in 1999, 2000, depending how you look at it, and the combined storage of these two units started to fall. And it really rocketed down during those really bad years, 2002 and 2004, and then kind of stabilized. And then this last year, it's really gotten even lower and very close to an official shortage. Okay. Those two droughts are colored. One is colored in this brownish color, yellow, and the other in the red color. They're fundamentally different droughts, as I'm going to explain to you in a second. But you can see the natural flow of the Colorado, after you take into account all the reservoirs and factor them in, has been steadily downhill. That's the dotted red line on this graph. The white line is the annual ups and downs. The blue line is a smooth curve going through the annual data, just to show you the sort of long-term change. And you can see the blue line dipping low during the 1950s, 60s drought, and you can see it dipping about comparable length down in the 2000s, in the current drought. But the trend is, in the dotted red line, is clearly down. This river is flowing less and less. Wonder why that is. All right, so here we see more data. We see the same two plots that I just showed you at the top, and then we're comparing it to how precipitation in the upper basin of the Colorado and temperature in the upper basin of the Colorado have changed over the same period. The upper basin of the Colorado River is where the water comes from, obviously, the water that we use here in the desert. First, look at precipitation. And the first thing I'd look at is the dotted red line. It's flat. There hasn't been a long-term trend in precipitation in the Colorado River Basin. There have been some dry periods during the 1950s and 60s, some wet periods during the 1980s and 90s, and more or less normal periods like during our current drought. Compare that to temperature, and you see something that looks remarkably like the natural flows, only in inverse, meaning the opposite direction. Look at the dotted red line. As the Colorado River has gone steadily less and less flow, temperatures in the upper basin have gone up, 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 up. And you can see during the 1950s, 60s, temperatures were about average, whereas temperatures during the current drought are well above average. This is hot drought. Hot drought to us means less water. Okay? Why do we have warmer temperatures? It's a global trend. Here's the global climate record from thermometers around the planet since 1880, and you can see that it's been steady warming. There are ups and downs because there's natural variability, but 2014 was a record, 2015, the biggest record ever. This planet is heating up. And that warming is global. This map shows where we have thermometers going back to 1901, and we can see 1901 to 2000 temperature change. In almost every corner of the planet where we have thermometers going back that far, there's warming, and this is why we've called it global warming. It's not because climate scientists are clever, okay? There is less warming. There has been no warming in the North Atlantic. As you'll see later, that's predicted by our climate models. The warming hole in the southeast has gone away since 2012 because 2014 and 15 it was very warm in that part of the United States. So we are experiencing global warming Arizona style. You can see in North America, outside of the highest latitudes, the warming is greatest in the Colorado River Basin. That is something that isn't just a bad trick of Mother Nature, that's something that our models predicted would happen. And it is happening. Okay, so what's ahead and how do we know this? How well do we know this? Let's turn to that. Because now we have a really important clue because what's already happening tells us a lot about what's likely to happen. It turns out the biggest source of uncertainty, there are many big sources of uncertainty, but I'm not talking about them today, except for this one, because it's the only one that's really relevant to our talk today. I'm only talking about the stuff that we have great confidence in. The biggest source of uncertainty is how much more greenhouse gas are we going to put in the atmosphere? Are we going to just go pedal to the metal and continue to burn fossil fuel and coal, oil, and gas, just like we have for the last 100 years in an ever-accelerating fashion? If we do that, we're going to get a very hot planet very quickly, and a lot of other climate change too. We're going to get a very hot planet, and you already can tell what that means for us, right? Just as warming has robbed us of 19% of our water supply in the Colorado, maybe 10% of that so far has been the warming, and the rest maybe a precipitation decline and other factors. Continued warming will continue to drain our water supply, and I'll show you more on that. But we have a choice, and this is what's actively being debated around the world now, in the media, in the public, probably in the presidential election. If we decide to cut our emissions, that means far less warming. So the beauty of climate change, really, is that we know all about this problem at this point, and we know how to stop it if we don't want what's to come if we let it go unchecked. And those numbers are big, right? It's a choice between 1.5 degree more warming, 5 to 7 degrees C. Okay, so for our neck of the woods, that's like 12, 13 degrees. This is just averaged across many models. Some models say more, some say less. All right. So, what do we have to have confidence in our projections? I want to give you a sense of what's going on in my mind to feel like I can stand up in front of you and say, I have a lot of confidence in what I'm talking about. I'd bet my house on it, okay? Not just my decrepit old truck or my new truck or my Prius, but my house, okay? Here's what's going on. My wife is shuddering. She's a climate scientist too, though. She knows what I'm talking about, okay? The first thing is we're going to have faith. We're going to put money behind science that is consistent with experimental evidence. Over 100 years ago, physicists and chemists were talking about CO2 and what it would do to the atmosphere if we put more in the atmosphere, based on experiments, based on well-established physics and chemistry, okay? So warming, we go into this whole debate knowing that if we put more greenhouse gas in the atmosphere, it's going to cause warming, or it's going to, and we know that warming will continue. Okay? It's consistent with ongoing observations. You know, as good as any model is projecting into the future, you really want to know that it's consistent with what Mother Nature's doing, right? That's probably something everyone in the room does. You get a forecast that it's going to rain, you look outside. If it's not raining, you say, I don't know if I'll bring my umbrella. But if it's raining, or if the clouds are like billowing, you're going to bring your umbrella, okay? So we're getting this warming. We're getting the reductions in stream flow because of that. The models are projecting that should be happening and will continue to happen if the greenhouse gases continue to increase in our atmosphere. Okay? The last thing is we have many models. We have many observations. Is everything consistent across the models? Do some models say, yeah, and some say, yeah? Or do all the models say, yep, you better worry about it? Okay? This is important too. All right? So for example, every single climate model says it's going to continue to warm. Every single climate model said it should be warming. Mother Nature says it is warming. All of this is consistent with experiments. You can bet your house that it's going to continue to warm. Not necessarily every year warmer than the next, but over the next coming decades, it's going to be hotter in the future than today if we continue to burn fossil fuels, as we are now. The only difference is some models, the coolest 25% of them, say that warming will only be, a couple degrees, whereas the warmest models are saying, yeah, it'll be a lot more than that. So this is where the uncertainty lies. Not if it's going to continue to warm, but how much and how fast. Contrast that with precipitation projections. These are all based on climate models, 40 of them. The bottom line here is that who knows? There's no trend in precipitation now, so Mother Nature says don't expect more or less. The driest models say it's going to dry out in Tucson, where the big dot is. The wettest models say it'll probably dry out in Tucson too, but it'll be wet up in the upper basin of the Colorado. The middle models say, well, not much change. Incidentally, the hatching, the slash lines, means not statistically different from zero. Okay? So the models here are saying kind of like what the observations are saying. We're not going to get a big change in precipitation. I'm not betting you anything on more precipitation. I just don't think it's that's a lousy bet. Okay, that's like a one-armed bandit in Vegas. All right? Why is that? It's because we have substantial uncertainty in how the position of our storm tracks are going to change in the future. A lot of the papers are saying the storm should move poleward in both hemispheres. We're seeing that in the southern hemisphere. We're not seeing it as clearly in the northern hemisphere. But could that be the reason we're in this drought? Getting a little less precipitation. We're not getting a lot less. We're getting a little less. Unclear. Not worth betting on. But the temperature change, definitely worth betting on. Are we going to have 4 to 5 degrees warming in the upper basin? Or are we going to get 5 to 7 degrees? Or are we going to get a whole lot less because we decide to stop polluting the atmosphere with greenhouse gases? We decide to stop burning fossil fuels. That's our choice. Now, let's say we don't want to do anything about it, okay? Remember those numbers I just showed you. 4 to 5 degrees, 7 degrees C. Okay, in a big study that was published just recently, and I was one of the authors, along with most of the scientists who were publishing papers on projecting Colorado River flow, we wanted to get the best answer because all our different studies were saying the Colorado River was going to have somewhere between 5 and 45% less water in it by the middle of the century if climate change is unchecked. We wanted to find out where the real answer lies by comparing all our studies in a very methodical way. We did this, and we came up with this one of many conclusions, one of which is warming alone will drive the Colorado River flow to decline 6.5%, plus or minus 3.5% per degree C. That means for every degree C of warming, we should get somewhere between 3 and 10% reduction in the river flow. Remember that, 3 and 10%. Okay, first, we want to say, why is that the case? How is it that warming literally cooks our water supply and boils it off? It doesn't really boil things. Okay, where is this water going? All right. Well, what's happening is the atmosphere is warming. That's well established. You can measure it with satellites. You can measure it with thermometers. You can measure it in many different ways. It's consistent with all the models. Okay? Because that atmosphere is warming, it can hold more moisture. Again, we can measure that in multiple ways. It's consistent with experiments. No surprises there. Okay? As that atmosphere gets warmer, it can hold more moisture. It demands more moisture. It's like a big atmospheric suck from the land surface into the atmosphere. So where does the water come from? First off, you have sublimation from snow. That's, if you remember back to high school, that's where you get snow and water in a frozen state going directly into water vapor. That's happening. You also have evaporation. That's the most obvious one from the surface. You have evapotranspiration from plants and soil. That's where the plants take the water to grow and to photosynthesize and then release it through their leaves into the atmosphere. That's actually the biggest way water goes from the Colorado River Basin into the atmosphere. But because we're warming the planet, now spring is coming weeks, I think 6 weeks earlier than it used to. So vegetation starts greening up earlier. It's greening up now in parts of the upper basin. Way early because it's been so darn hot. And because of that, the evapotranspiration can kick in earlier and move more water from the soil and plants into the atmosphere. You're getting more rain and less snowpack. That's not good for river flow. And you're getting a whole bunch of other positive feedbacks, amplifying feedbacks that make this situation worse. All of these combined to take warmer temperatures and turn it into less water in the Colorado River. So here's some projections that Brad Udall and I have produced, noting first that this is looking at change by 2050 for all our models that project climate in the basin. These are all the state-of-the-art models that we have around the globe. We took them all and we plugged in that 3 to 10% change per degree C. First off, you can see in red in the far left the amount of loss we've experienced during this drought. As I mentioned before, this drought has averaged 19% less flow over the 15 years of the drought. And we think we've had about a degree C warming, so probably up to about 9 or 10% of that 19% is due to the warming. And the rest is due to precipitation decline. And then there's a mysterious several percent that we can't explain. Maybe that's because the sensitivity to warming is even greater than the 6.5 plus 3.5%. Okay? But if you take all those models then and you look at the range of warming that's projected to occur for high emissions on top, meaning business as usual, and moderate emissions, meaning the kind of emissions that were agreed to in Paris last year, you can see that by the middle of the century, we'll lose somewhere between maybe 20 to as much as 35 or 40% of our water in that river. Okay? This is the cost of global warming for the Southwest, for Arizona and Tucson. A lot less water. By the end of the century, you really see the difference between these emission choices. Should we all decide to get behind the commitment made by President Obama in Paris, we'll have a lot more water in our river than we would otherwise, but we'll still lose a good deal. So for moderate emissions, the Paris Agreement suggests that we will lose somewhere in the range of 25 to 40% of our water. If we let business as usual go unchecked by the end of the century, our river could be 40, 50, 60% less water, just due to the warming. Okay? What's the big deal? Okay, because I know there are people out there that like to go to Vegas. All right? Let's bet on more precipitation. That'll do the trick. Well, we calculated how much more precipitation we need. We need 15 to 30% more, depending on which scenario, warming scenario. Okay? You want to make that bet? Not so smart. Remember, our models don't think it's a good bet. Observations, Mother Nature doesn't think it's a good bet. But I'll tell you what, I'll give you a gradual change, increase in precipitation. Okay? And then I'll tell you why it doesn't matter. Okay? In this same study, we pointed out that there's abundant evidence now from tree rings and other work that we live in a drought-prone region. Not only a drought-prone region, but naturally we've had droughts that last decades. Multi-decadal megadrought. This whole story came to be because we have a tree ring laboratory, and now tree ring analysis is widespread around the country, but these guys have done a fabulous job of documenting the hydrologic and climate history of the Southwest going back centuries. And we've done the same thing with caves and lake sediments and other sources of information. So even if precipitation goes up against all odds, we're going to hit these megadroughts. What do I mean? Here's a tree ring-based reconstruction of the Colorado River flow going back 1,200 years. You can see the year-to-year values in white with the errors in gray. And you can see the long-term average flow in the dotted line, the white dotted line. You can see the level of these megadroughts that are colored, they're shaded in these yellow-brown colors. You can see that during these megadroughts, we had 15% less flow in the Colorado. Okay? And these megadroughts don't just last a couple years, they last decades. In fact, the longest one we found so far in the headwaters of the Rio Grande and the Colorado, this isn't just a Colorado story, even though I'm making it that way for us. The longest drought we've so far found, looking at this marvelous archive of ancient climate, is 50 years long with 1 year above normal. All right? So even if we're able to get an increase in precipitation because of global warming, remember, I sure as heck won't bet on that. But even if we were able to get it, we'll hit one of these mega droughts and it just won't matter because it means less precipitation. It'll at least counterbalance that increase in precipitation. What's the risk of a 35-year-long megadrought? We have additional work that illuminates this question. Without anthropogenic warming, the risk is only 10% or less. It's really about 8%. Okay? This is the risk of a natural megadrought. With anthropogenic climate change, the odds of this megadrought, scale of megadrought goes above 80%. Okay? That was recently published last year by a former grad student from the University of Arizona and colleagues at Columbia University. So you want to talk real problems, you talk about this temperature increase that we seemingly are doing, some of our leading politicians say doesn't exist or isn't a bad thing. Not sure what they're smoking. The science is very clear. We got this temperature problem, but we also have this megadrought problem, and they're caused ultimately by the same problem. We'll get megadroughts naturally, but the odds of them go way up with climate change. Okay. What's the cumulative effect of all of this? What does climate change mean for Arizona? Okay? We get a megadrought. It means 15% less water. Okay? So even if average precipitation goes up, which it isn't probably going to do, we're going to get these megadroughts, and that means less water. Add in the temperature factor, and we could easily have over 50% less water because of that. Add these together, and we don't have a sustainable water supply anymore in the Southwest. Remember the cities that I talked about? LA, San Diego, Phoenix, Vegas, Salt Lake, Denver, Albuquerque, and the most important of all, Tucson. No sustainable water supply. Okay. It is about our water, but it's not just about our water. The beauty of this series has been to highlight all the other things that climate change means for us in the Southwest, as well as for people around the world, because the same problem that we're getting here now, already observing, was predicted to occur, is occurring, is global. There are other semi-arid regions that are getting the same problem. Okay? But we also could have extreme heat and other health problems. We could have these ecological problems, large wildfire and forests transforming and dying. Agricultural impacts we didn't really play up, but it doesn't take a rocket scientist to figure out if we lose our water supply, we have some serious problems in our ag sector. Endangered species. The list goes on, and we've heard about many of these factors in this lecture series. But to me, the big thing is water. Without water, what happens to all your mortgages? Yeah? What happens to those wonderful projections we always get from Phoenix? Oh, we'll promote more job growth. We need water, folks. And the University of Arizona is figuring out how we're going to be able to get by with less water. We're going to be able to reuse water. But if we really want to thrive in the Southwest, in the desert, we don't want to just give away our water supply so the oil companies and the coal companies can reap huge benefits. Or do we? That's our choice. Okay? So climate change is a sure bet. Okay? We have three choices for dealing with it. Remember, I'm not telling anyone what to do here. My job is just to illuminate the choices. We can adapt to this. We can deal with it. I challenge you all to figure out how we're going to deal with a lot less water and just let things warm up. How we're going to deal with temperatures in Tucson that are a lot hotter than they currently are in Phoenix in summer. Let's figure that out. That's one option. And it's a worthy goal because we're going to get some more climate change no matter what. So we better figure out how to deal with some of it. But we're not going to be able to adapt to all of it, probably. We have to figure out, as fellow citizens, what's just too much. What costs too much? Don't forget that sea level rise on the coast. Don't forget all host of other problems around the country. Don't forget a host of other problems around the world. Don't forget what our military might have to do in terms of humanitarian missions as well as missions related to conflict, like Syria, which had a climate change component behind it. We all have to decide, is all that acceptable? If it's not, we can slow down the emissions of greenhouse gases. We can slow down our use of fossil fuels. Okay? In the future, I think we'll end up doing both, and it's just a question of how we balance all this out. That's something we're going to decide perhaps in this election. Okay? Now, this has all been pretty depressing, right? Yeah. And I don't usually do a great job, but I usually try to end my lectures by being less depressing. But I have to say, this last half a year has been phenomenal for me. I'm an optimist to start with, and I truly believe now that we're in a situation like our forefathers were at the beginning of the last century. We're going to leave behind fossil fuel just as they left behind steam as the primary energy source. We're going to move on into electric vehicles and other technologies just as they moved out of horse and buggy. We're going to live through this transition. This transition is only going to be taken maybe a decade or two, but we're going to look back even in 5 years and say, holy cow. And it probably won't be using the word cow, right? Because if you look at the news now, it's truly amazing what's going on. The first good piece of news is the climate science now is just rock solid. You know, you still have a few crazies out there who are saying it's not happening, it's not going to be that bad. If it happens, if just a few nuisance flooding will continue. You know, the science is pretty much settled. And right now it's all about figuring out exactly how much it's going to warm and exactly what the other impacts will be. The good news, though, is we know what the problem is. We've gone to the doctor, and the doctor has really diagnosed our problem, and we know what the cure is. And it's just our choice as whether which cure we want to go with, adapt or mitigate, or some combination. We have time to do it, but we have to act fast. What are some other reasons for optimism? They're growing really fast. The cost of solar and other green solutions, energy, but also water-saving solutions, are plummeting. These are not commodities. We're moving from an energy world that is commodity-based, where we get these big increases in prices and big dips in prices and big, these cycles. These are technology. This is like your hard drive or your TV screen. It's only going to get better and better as the prices go less and less. Okay? Totally different type of technology. And all the signs are good. These prices are plummeting on solar and on wind. Okay? The countries of the world, all of them except a couple, agreed in Paris at the end of last year that we're going to work as a world, as a planet, to limit greenhouse gases. This is a total game changer. This is not Kyoto. This is not Copenhagen. This is big pledges and an agreement to meet at irregular intervals to review how well we're meeting our pledges and probably to ratchet them up because we're going to solve this problem. That's what they're saying. And there's proof that this is happening, not just in the United States, where we have a whole bunch of new laws and regulations, but around the planet, where most of the greenhouse gases are being generated now. There are this ever-increasing, accelerating number of laws to limit the greenhouse gases, to figure out how to adapt, not just in the rich countries, but in the poor countries as well. So the rubber is really hitting the road. People are not just saying they're going to do things, they are doing it. Just like in the United States. What's really remarkable is right now, oil and gas is like it was in high school. It's time to go out and buy that hot rod again or something. It doesn't matter. We're deploying more solar and wind than ever before. Okay, the prices are plummeting. It's almost as if this world is ignoring that old world, okay? Just like we're in the beginning of last century. Who cares about steam ships and sailing ships? We're moving to a new world. Now we're moving to this, low carbon energy. These are coming out like every week we're getting stories like this. It blows me away. In the United States, for the first time, as we build out utility-grade power, electricity, for the first time, we're going to build more renewable, in this case solar, utility-scale electricity capacity than any other source. Number 2 is gas, number 3 is wind. It's remarkable. But we get totally taken to the cleaners by China. China is totally committed to reducing their greenhouse gas emissions as well. And this is just one of their solar installations from last year. They already added 15 gigawatts. We're thinking of 9 gigawatts this year. Last year they did 15 gigawatts. These are big numbers now, okay, just in the news. You just see this growing. This was in the newspaper again this month. Last year, let's go back like 3 years. People were speculating that by 2030, 2025, 2030, China would hit peak coal. Coal emissions would start to, emissions due to coal would start to peak out and go down. Then last year, it started. And everyone said, oh, it's just the slowdown in their economy. This year, they went down more. 2014, 2015. China is hitting peak coal much earlier than anyone thought they would. Okay? Our emissions have already peaked as well. Okay? If we go back to pedal the metal coal and oil, yeah, they'll go back up, but it looks like we're beyond that now, even with the price of oil at $30 a barrel. Amazing. You got to be optimistic when that kind of thing happens. Again, just a couple weeks ago, what came out is news that by the U.S. government has basically figured out the holy grail of battery storage, and now it looks pretty good bet that electric cars will become cheaper than internal combustion vehicles over the lifespan of the car within 10 years. It's amazing. 10 years from now, we might look back and say, the people are still driving around their cars. It's like, those are antique shows or something. Okay, why is all this happening? This is the most amazing reasons for being optimistic for me. The technology's caught up with us. We don't even need the utility grade storage. We could have a distributed system now if we built the transmission lines, everything off the shelf, okay? But of course, the technology breakthrough after technology breakthrough is just going to accelerate, and you can't really say where it'll be 10 years from now, but I'll bet you it won't be in a fossil fuel economy anymore, right? And what's really remarkable is a sizable majority of Americans across this whole country and every state of the union, the survey numbers show this, believe global warming is happening and that something should be done about it. These are data from Yale. We did our own survey here with colleagues at Stanford University to see how people in Arizona, this marvelous red state we live in, feel about climate change. You'd think we're less aware of this issue, less willing to talk about it, less willing to do something about it. Some of our politicians are that way, and you sort of think all of the citizens of our state must be that way too. It turns out it's the farthest thing from the truth. 75% of Arizonans, 3/4 of us, believe global warming will be a serious problem for Arizona, the US, and the world, and that will hurt future generations if nothing is done to reduce it in the future. You can go to our survey on our Institute of the Environment, U of A's Institute of the Environment website. There's bipartisan agreement, actually tripartisan in this state, right? Republicans, Independents, and Democrats, a majority of all of them agree that the US government should act to reduce greenhouse gas emissions. That Arizona government should act to reduce greenhouse gas emissions. This isn't the debate of like 10 years ago, where it was like, oh, is global warming happening or not? What do you believe? No, this is like feeling our politicians should get off their tails and do something about the problem, whether you're Democrat, Republican, or Independent. Okay? And maybe that's because the citizens of this state realize that climate change is really a problem for this state. They haven't even seen these new results that really demonstrate how bad the problem is if we let it go on. But they already are aware that it's not a good thing. They're already aware probably that if we stop burning all this fossil fuel, our air quality will get better, that we'll have less health problems, less asthma because of the polluted air. Yeah, that's a freebie if we solve the climate problem. Okay? They're probably aware that, hey, it's sunny in Arizona. We could become the Saudi Arabia of renewable energy for this country and Mexico. Yeah. They're probably aware that when we hit 2008, Arizona tanked harder than many of the other states of this great union. And that if we had an economy that was diversified and didn't just depend on people moving here, life would be better here, jobs would be more secure here, we'd have growth that really made sense and that was sustainable. Okay? Not only that, we have 3 great universities here, of course, one really great one. These 3 universities, particularly U of A, are putting a lot of effort into the same kinds of energy, water, and other solutions that need to be used around the world to do the same thing we need to do here to solve our problem. People from around the world will be buying these technologies to solve the similar problems. We've all agreed in Paris to solve these problems. Do you want them going to China for the solutions? Maybe for the manufacturing capacity there. But the ideas, the innovation should come from Arizona. The jobs should be here. Okay? We get a sustainable economic engine. Maybe the people of this state know that, and that's why we're more in tune with the need to solve this problem and do it soon. Okay? So to conclude, climate and water solutions exist. Okay? We have a big problem, but we know how to handle this problem. We know how to solve it. The globe is on board. There's no more saying, well, we're not going to do anything because China's not going to do anything. That is so 1990s or something, you know? The whole world is going, and not only that, the whole world, many of the countries like Europe and China are going faster than we will. And do we want them to reap the economic benefits of that, or should we reap the benefits of that? Okay, I think that's why the citizens of this state think, let's do it. Okay? And I think that's the big reason for optimism. There's a public consensus here. A bunch of our politicians are kowtowing to the special interests, and they're trying to deny this or say it's not a problem. You know, it is a problem. We have the solutions, and the benefits of dealing with this problem are probably far greater than ignoring it. Thank you.